Hey, ladies and gents, welcome back. This is Anthony with Embrace Tutoring Educational Services, and today we're going to be focusing on the SAT Practice Test 1, Math Questions 21 through 30. So let's get started. Question 21 states, dreams recalled during 1 week. Let's clear this up a little bit so that we have a little bit more room to write. It says the data in the table above were produced by a sleep researcher studying the number of dreams people recall when asked to record their dreams for 1 week. Group X consisted of 100 people who observed early bedtimes. Group Y consisted of 100 people who observed later bedtimes. So I care about Group Y compared to Group X because it appears as though quickly scanning the data, that's how it's broken up into. If a person is chosen at random, from those who recalled at least one dream. Okay, so recalled at least one dream, so I don't care about none, right? What is the probability that the person belonged to group Y? So first of all, we had to remove none because we want at least one or more, which means 1 to 4 as well as 5 or more all includes at least one dream. Now, we're also going to be focusing on group Y specifically. And group Y, right, what is the probability that the person belonged to group Y? And that probability is going to include the 11 people here, right? 11 people as well as the 68, right? So 11 plus 68, and that's going to be over the total, right? So this is the group Y people, really where we want to be focusing on rather than just group X. And we want to be thinking about the totals. So here we have the total individuals of at least 1 to 4, which is 39, and the total individuals of at least 5 or more dreams, which is 125. So if I were to take these, right, 11 plus 68 is going to be 79. And then if I did 39 plus 125, I'm going to end up getting 164. And so it looks as though my answer choice needs to be 79 over 164, and I'm going to find, and that's answer choice C. It's not very clear right here, but let me scroll down for a second so that way you can quickly see it. Yeah, 79 over 164, correct. Okay, so moving on to problems 22 and 23, I see here that it says the questions 22 and 23 refer to the following information. You want to do your best to let the questions guide you. So when you get information like this, you want to do your best to skip the table and get to the questions. Let the questions guide you for specifically what you need to be looking for in an effort to save time. It says, which of the following best approximates the average rate of change in the annual budget? You care about the word annual being per year, right? Per year for annual, right? In the annual budget for agriculture natural resources in Kansas from 2008 to 2010. So I see I have 2010 to 2008. So I'm gonna be talking about over the course of 2 years altogether. Okay, so I care about that. So this is going to be because the rate of change is going to be based on per year, and I'm seeing here this is a 2-year increment. Now I'm going to quickly go to the table, and I'm looking for agriculture and natural resources in Kansas. So agriculture, natural resources, here's my 2008, and here's my 2010. Now, I want to know what is the difference here per year, right? What's the annual rate of change per year? So I'm going to take my 400,088, right, 106, and I'm going to subtract that from my 350,000 or 358,708. I'm going to subtract that in my calculator, and I'm going to get what looks to be, well, notice here, I have 488 minus 358. I'm going to get approximately, let's say, 130,000. Also, quick tip is that I'm scanning my answers relatively quickly, and I'm noticing my numbers are not even in the same ballpark. So why is that? Why is it that this says 50 million and some of my other answers, if I were to scroll down a little bit more, say 50 million, right? 65 million, 75 million, 130 million. Why is that the case? Well, the reason being is that if you were to look back at the table, it tells you that this is in thousands of dollars for the unit. So this here is really 130 million, right? In terms of the 130 million But remember, this is based upon the 2-year increment. So here I have 130 million is the rate of change, right, for my 2010 budget to my 2008 budget, but this is based out of 2 years. So I want to divide by 2, and this is going to give me approximately 65 million, right? My 65 million are the rate of change per year, which is my reflecting of my annual budget. So 65 million is going to be my best possible answer. So I'm going to clear this. I'm going to scroll down, and it is. It's going to be choice B, being 65 million per year. So a few quick tips. It definitely helps you to know annual budget, and it also helps you to know immediately what you're looking for. And lastly, being able to read the data in terms of thousands of dollars so you don't get stumped with that. Because I was immediately thinking, well, why is my answer seem so off? But just the truth is, when I went back and I read the table and I just quickly skimmed it, it made a lot more sense. For question 23, of the following, which program's ratio of its 2007 budget to its 2010 budget is closest to the Human Resources Program's ratio of its 2007 budget to its 2010 budget? So let's quickly go and scan and find Human Resources. So here's my Human Resources 2007, and if I were to go and find my Human Resources for what's 2010, right? So here's my Human Resources 2010. I see here that I have, and just do your best to try and round up or round down so you're really not putting these in your calculator to really simplify it. So here I'm gonna round this up, and I'm gonna say that this is approximately, right, in this connotation, 6 million. Okay, and then here I'm gonna say that this is approximately 4 million. Now my ratio is my 4, right, over my 6 for my 4 million over my 6 million, which is going to simplify to approximately 2/3. So the reason why I'm attempting to simplify this is so that way I don't get boggled down with actually trying to, because the word, where is it here, is closest to, right? The wording is closest to is really relative. They're saying approximate. So they want something, what is the best estimate that's going to be equal to 2/3? Because the human resources budget, 4 million over 6 million is going to equal to 2/3. Now I want to find a budget within the 2007 also going to 2010. So I'm going to get rid of these, right? Because I don't want 2000, I don't want to get complicated with my 2008, my 2009. And I want to try and find another ratio that's essentially 2/3. And I want to find something that's pretty straightforward. So I'm looking here, right, to there. No, that seems like it's a 3, right, to a 5, or a 4 to a 5. Here it looks as though it's 2 million. Here's 3 million. Whoop, we may have a winner. That may be the best possible answer. Here I have 14 to 14. That's definitely not it for general government. Here I have, right, 1.5, 1.7, also not it. Public safety, also not it. Okay, so if education is in my answer choices, it is. Okay, education is your winner. It's going to be your best possible answer. And just to very quickly clarify, it would be the 4 million over the 6 million, just because we're looking at the budget for 2007 over the budget of 2010. So just in case you're wondering why I stacked the 4 over the 6 in order to get to 2/3. It's the 2007 budget over the 2010 budget. Question 24 states, which of the following is an equation of a circle, so an equation of a circle, in the xy plane with center 0, 4, and a radius with the endpoint of 4 over 3, 5. So xy plane with the center of a, I see. All right, so one of the first things you're going to need to be able to recognize is what is called the equation of a circle. So equation of a circle. And this particular equation is going to be written as x minus, and the value that goes inside of here is going to be the x of center. In this case, the x of center is going to be 0. So the x of center is here. And this is going to be squared. And then plus your y minus. And here is going to be your y of center. And within your y of center, you're going to have your 4, okay, right? Because whenever you see this notation, you're thinking x, y, and they're telling you the xy plane with a center of this data point. So 0 I'm getting from that 0, 4, right, 0, 0, and I'm getting the 4 here from the y. And I then am able to solve, and this is going to be squared, and I'm then able to solve for my r squared, right? And what I can then do with this, right, it says and a radius with an endpoint of this value. So I will actually also need my distance formula, but here I'm able to solve this through. So x minus 0 is going to be x, right? I'm going to end up doing x squared, and this is going to be plus y minus 4. So I'm going to get y minus 4, and this is going to be squared equals r squared. Now I care about this because I can immediately glance over and try and get a good idea of what are a few possible answer choices. I see that here I have x squared, x squared, x squared. Okay, so everything a through d does contain x squared. But here I have y minus 4, and some of these have y plus 4. So I'm going to eliminate b, and I'm going to eliminate d. And the next biggest question is, well, how do I solve for my r squared, right? How do I end up getting, because it's either going to be 5 over 3 or it's going to be 25 over 9. Now, I've just solved for my equation of my circle, but the next step to do is what is called the distance formula. Now, my distance formula is going to be equal to, and I'll write this here, distance formula. And the whole purpose of this is to really solve for this r squared and this missing piece between a or c. So here I have r squared equals, now I'm going to have 4/3, which is my and a radius with endpoint. So this is my endpoint, right, of my x endpoint, right? 4/3 is my x, right? 5 is going to be my y. So these are my endpoints, and this is my center of the circle. So I have 4/3 minus 0, because that's where I'm starting from in terms of my x. This is also going to be squared, plus, now my y2, or my endpoint, is going to be 5, minus my x, or I'm sorry, minus my other, minus the 4, which is going to be the center of the y, and this is also going to be squared. So here I have 1, right? 5 minus 4 is going to be 1 squared, plus 4/3 minus 0 squared. So here I have 4 over 3 squared plus 1 squared, and this will end up giving me r squared. But you can tell that I want to add these together, but the issue is simply going to be I first have to distribute the exponent across and then find a common denominator to truly add them. So if I'm going to distribute this exponent through, it's going to be, so the 4 squared and the 3 squared, I then end up getting 16 over 9. But remember, this 16 over 9, or the 4/3 squared, is going to be then added to the 1 squared, and the 1 squared is going to be 1. But how do I take 16 over 9 plus 1? Well, what's my common denominator? I would simply make it 9. Right? 9 would be my common denominator. And if 1 was here within the top of the numerator, I would then make this a 9 to make the 9 over 9 still equivalent to 1. Now, 16 plus 9 is going to give me 25 over 9. My answer should have something to this extent, being the r squared, because that's what I solved for in the first place, right? I took the r squared, and then I was able to simplify these things by solving for the common denominator here, right? I first had to solve this through, distribute the exponent, then solve for through the common denominator, then I have 25 over 9. So I can plug this back into my original equation, which is then going to be the x squared plus y minus 4 squared equals r squared. So my r squared is going to be the 25 over 9, making answer choice A my best possible answer. Problem 29 states h equals negative 4.9 t squared plus 25. It says the equation above expresses the approximate height h in meters of a ball t seconds after it is launched vertically. So the height is representing the fact that the ball is immediately traveling upward, right? Vertically upward from the ground with an initial velocity of 25 meters per second. After approximately how many seconds will the ball hit the ground? So this seems to be your biggest hint. thus far. Because when the ball hits the ground, it's no longer moving in the upward direction. So your height is going to be equivalent to 0. This is when it comes back down and officially hits the ground, right? It hits the ground, it's no longer moving in an upward velocity. So if you know that h equals 0, then you're able to say negative 4.9 t squared plus 25t. And they're asking you after approximately how many seconds? Well, seconds is an incremental unit of time, and it also tells you a ball within t seconds. So really what they want you to do is they want you to isolate and they want you to solve for t, knowing that when the ball hits the ground, h equals 0. So how would I end up doing this? So I'm first going to subtract 25t on both sides. So minus 25t here, minus 25t here. I would cancel those out. And this then becomes 25t equals negative 4.9 times t squared. I'm now going to divide by negative 4.9 on both sides to be able to isolate t by itself. And you can probably see where this is going because of the 25 if I'm able to subtract this. So this is negative 4.9. I'm going to take this. This is approximately going to be 5, right? From this information, I can tell that 5t equals t squared. Now, how would I end up actually getting rid of, just to isolate for t by itself? Well, I can do, say for instance, if I were to divide both sides here by t, then I can simply simplify this here. And if this is t, right, t squared over t, this would end up simplifying as well, because this is like saying t to the first power, t squared. I can simplify this, and this would become 1. So 5 equals t overall, which would make D your best possible answer. Okay, question 26 states, Katrina is a botanist studying the production of pears by 2 types of pear trees. She noticed that type A trees produce 20% more, so this seems to be a percentage question, more pears than type B trees did. Based on Katrina's observation, if type A trees produced 144 pears, so type A trees produced 144 pears, how many pears did type B trees produce? Well, we know that type A trees are 20% more than type B trees. So just assuming that, let's say type B trees are, just in general, these are 100%, right? So it's 100% of type B. Well, we know type A trees are your type B trees, right? Your type B, as well as 100 or 20% more. So they're 1.20, right? This 1.20 is signifying the fact that it's 100% plus the 20% more. So not only are they 100% of the type B, but they're also 20% more, which is where the 1.20 is coming from. So type A equals type B times 120% more. Right? Now we also know that type A is equivalent to, let's say, 144 pairs. Okay, altogether is what they mentioned. So type A trees produce 144 pairs. But we're aware that type A also equals, let's just say TB, okay, so type B and 120%. So now we can solve for the actual amount of type, or the actual amount of type B trees there are, right? We can solve for the original value of what they were, because it asks you to do how many pairs did the type B trees produce, and if we were to divide, let's say our 144 equals your type B times your 1.20. If I were to divide both sides by my 1.20 here, so here's my 144 divided by 1.20, I'll end up getting my answer for type B. So I'm going to divide these out, and my 144 divided by my 1.20 is going to give me an equivalent of 120 pairs. Now 120 pairs should give me what my type B should be, and B is going to be your best possible answer. Okay, question 27 says a square field measures 10 by 10 meters. 10 students each mark off randomly selected regions of the field. Each region is square and has a side length of 1 meter. Now, so immediately I'm able to recognize, well, I have a huge box here, right? 10, 10, 10, right? All the way through. And this drawing is obviously not drawn to scale, but essentially in every single one of these boxes, I have a 1 meter by 1 meter, right? So it's 1 meter across, 1 meter down, right? So it's a 1 meter by 1 meter. And no two regions overlap. The students count the earthworms contained in the soil to a depth of 5 centimeters beneath the ground surface. I'm underlining this because it's a number, and I'm going to see how maybe this plays into the overall question being asked. The results are shown in the table below. So here are my regions. I'm noticing that there's 10 of them. There's 5 here. There's 5 here. So there's 10 as they mentioned, and 10 students randomly selected for 10 different regions. It says, which of the following is a reasonable approximation of the number of earthworms to a depth of 5 centimeters beneath the ground surface? So the 5 is really just telling me where they buried it to, but it's not really relevant information for this problem of what I need to know. So I'm actually going to kind of get rid of that. They're just using it as a labeling method where they had to put in the earthworms 5 centimeters beneath the ground surface. What I care much more about is the fact that there's 10 by 10, meaning that altogether there's 100 meters, or I guess you can even say there's 100 boxes of this 1 squared meter, right? So there's 100 boxes within this grid that the students are utilizing within their square field measurements. And the question is asking, which of the following is a reasonable approximation of the number of earthworms to a depth beneath the ground surface and the entire field? So if I know that I have 100 boxes, and if I know that for every one of those boxes I have 1 squared meter, then I'm trying to approximate, well, how many earthworms do I have, let's say, question mark, per 1 meter box? So for every 1 meter box, if I can figure this out, then I can simply just multiply that by 100 in order to approximate. I also quickly notice that all of my answers seem to have a 15, right? Or 150, 1500, 15,000, 150,000. That's most likely because they're taking the average. So I'm looking here within the 10, right? The first 5 regions, second 5 regions. It seems that my middle numbers are falling right around 150. Now, logically, you can add all these up if you wish to and attempt to approximate. And I believe that just scanning this forward, and if I were to plug this in real fast, I believe I want to get 1,471, and I have 10 different regions altogether. So I want to say that's about 147.1. This is per box, and that's approximately 150, which is where they're coming up with these 150, 1500, 15,000, and 150,000. So I'm going to estimate, well, if I have 150 earthworms, and this is simply just per 1 box, well, if I have 100 boxes, right, 100 boxes, then, right, so I'm going to do this in order to eliminate the units in terms of unit conversion. Then I'm going to end up with 150 times 100, which should end up giving me approximately 15,000 earthworms altogether, which I'm abbreviating with EW. So my best answer should be 15,000, and I believe C is your best answer. Okay, question 28 looks to be system of inequalities problems. I see a graph here asking about quadrants, and it says if the system of inequalities of y is greater than or equal to 2x plus 1, so I'm going to very quickly just write this down on the side, 2x plus 1, and y is greater than 1/2 x minus 1, so here I have 1/2 x minus x minus 1, then is graphed in the xy plane above, which quadrant contains no solution? So essentially what we're going to do is we're going to do quick graphs for both of these, and then we're going to attempt to display, well, where do these graphs not run into within the actual quadrants, right? Is it going to be quadrant 1, quadrant 2, 3, or 4? So let's quickly graph the y is greater than or less than 2x plus 1. So how do we do this? Well, let's quickly write down a few little dash marks. 1, 2, 3, 4, 5. We'll even go to 6. Then we have 1, 2, 3, 4, 5, 6. Right? I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, I'm going to continue to line out a little bit. The only reason I went to 6 was just to make sure that when going up in terms of the slope or down in terms of the slope, I was able to draw a long enough line. Here I have a 1, right, for a positive 1. Well, what's the important of that intercept? That means that when x equals 0, as if I were to plug in 0 here for that x, that tells me that my y equals 1. So if I were to say when x equals 0, I know that my y is going to equal 1. So there is going to be my starting point here. When x equals 0, my y equals 1. Now I also know that I have 2x, which means that this is going to be my slope. And as we previously discussed on the SAT, make sure that you use rise over run to kind of simplify things rather than doing y2 minus y1 or over x2 minus x1. So I'm going to go up 2, 1, 2, and I'm going to go over 1. And I'm going to go up 2 again, I'm going to go over 1. I'm going to go up 2 again, I'm going to go over 1. Now I'm going to come back down. I'm going to go down 2 here, right? So here's my initial point when x equals 0, y equals 1. I'm going to go down 2, and then I'm going to go over 1. I'm going to go down 2 again, then I'm going to go over 1. And I'm going to go down 2 again, I'm going to go over 1. Notice why I ended up drawing the 6 dashes, so that way I can just draw it all the way across, because it's a rough illustration, so you want to try and make it as accurate as possible, given the fact that there may only be like a small piece of one of these quadrants that isn't touched. And then here I have 1, 2, 3. Okay, so currently I'm in all of majority of quadrants 1, 2, and 3. It also tells me that it's greater than or equal to, so I'm going to shade the rest of these quadrants here, right? It's touching all of these spots here. Now, let's do the other equation. It says y is greater than 1/2 x minus 1. So when x equals 0, right, when x equals 0, what is going to be y? Y is then going to be negative 1. So I'm going to start over here. So when x equals 0, right, y is going to be negative 1. So I'm going to start at this particular point for this data set. And if it's easier for you, I'll actually put it in a different color. That way you guys can see it. So I'm going to recolor this in here. That way you guys can. So this will be the red equation, and the other one will be the blue equation for you guys. So here I have 1/2, right? 1/2. This is going to be up 1 over 2, right? So I'm going to slide up 1. I'm going to go over 2. I'm going to slide up 1 again. I'm going to go over 2. Slide up 1 over 2. Okay, so here I am. I'm going to slide down 1, and I'm going to go over 2. I'm going to slide down 1, go over 2. You can sort of already tell what's happening. I'm going to slide down 1, go over 2. This also says this greater than sign is a big hint, because that greater than sign means that I'm going to stay on this side, right? This side of the quadrants, meaning that the quadrant that seems to be your best possible choice, right? Because it says it contains no solutions to the system, is quadrant 4, right? You don't see anything that's really passing through quadrant 4. So C is going to be your best possible answer choice. Problem 29 states, for a polynomial p of x, the value of p of 3 is negative 2, right? So what we know is that, once again, when you think of p of 3, you think of y, right? This is representing y. We know that this is the x value. So what we know thus far is that when x equals 3, y equals negative 2 overall within this particular polynomial. It says, which of the following must be true about p of x? Now, this is going to be based upon a theorem, and to save us a little bit of time eliminating some of these particular answer choices, and because the theorem is fairly complicated, I definitely suggest, one, you go and you review your polynomials. But to speed up this process, I'm actually going to show you one of the particular answer keys that are provided within the bubble sheets. And once again, all the answer keys as well as the practice tests are completely available at www.embracetutoring.com. So question 29 is, if the polynomial of p of x is divided by x minus 3, the result can be written as, and this is the theorem that I'm referring to that can be fairly complicated that you want to go and you want to review, where q of x is a polynomial and r is the remainder. Since x minus 3 is a degree 1 polynomial, the remainder is a real number. Hence, p of x can be written as p of x equals x minus 3 q of x plus r, where r is a real number. Therefore, when eliminating these and solving through, D is going to be your best possible answer. Okay, we're in the home stretch. Question 30. It says, which of the following is an equivalent form of the equation of the graph shown in the xy plane above, from which the coordinates of vertex A can be identified as constants in the equation? Okay, so here I see that this is the equation of this particular vertex, and here is my point A. Now, it does seem as though it's definitely under 1, so I would say the x is 1, but it does seem, it may be between, I guess, minus 15 or minus 16. So so my points here are going to be, let's say 1 and minus 15, but it could be between minus 15 or minus 16, somewhere in that. The question says, from which of the coordinates of vertex A can be identified as constants in the equation? Now, in order to do this question, you need to know what is called completing the square. And if you were going to set this up in order to actually do the completing the square equation, then you would have your y equals, and I'm going to take this equation up here, right? This is going to be my y equals x squared minus 2x minus 15. I'm now going to separate this first part where it's going to end up being y equals x squared minus 2x. But so here's the trick when you're doing the completing the square. You have to take half of this value, half of the middle number, and then you want to take that value and you want to square it. So you then take that value and you square. So minus 2 times 1/2 is going to end up giving you negative 1. I then want to take this value and I want to square it in order to complete the square. So then I'm going to say negative 1 squared is going to be a positive 1 here, which is what I'm going to end up putting. So I have a negative 2 here in the middle. I'm going to take half of that in order to complete my square for the step 1 of completing the square. Then I'm going to square that number, right, negative 1 squared, which will give me positive 1. Now, I'm still going to have my negative 15 here on the outside, right? That's still going to stay complete. But because of the fact that I added a positive 1 here, I now also have to add a negative 1 on the outside to account for that positive 1. So altogether over here, I'm now going to have negative 16, which means that most likely my answer will be D, given the fact that I'm going to have my negative 16 here on the outside. So it definitely doesn't seem like it's A or it's B. It seems like it's between my C and D. But just to quickly clarify, and I'm pretty sure it is D when we end up kind of factoring this out. But here, if I were to have my, let's say, x squared minus 2x plus 1, if I were to break these down, I see here this is a negative. I also see here that this is a positive, meaning that both of these will most likely be negative. Once again, the hint is, right, I would have to take this number, right, both of these numbers together would have to be multiplied by each other, and that the negative number times the negative number would give me the positive number. And it seems as though because this is positive 1, these are both going to be x minus 1. So if this is x minus 1, then it's going to be x minus 1 squared minus 16, which ends up giving me the answer yes to D. So D is going to be your best possible answer. Okay guys, that's it for this video. Please make sure to visit embracetutoring.com if you have any particular questions. You're also more than welcome to post your questions below and we'll happily get back to you.